Welcome back. In this video, we are going to take a look at dividing polynomials. So in our first sample problem here, we're going to divide our trinomial in the numerator by this monomial. Okay, so as you can see here, 5x, our denominator, is a common denominator. It's common to each of these three terms. So we can rewrite this as 10x cubed over 5x minus 25x squared over 5x plus 35x all over 5x. And this really becomes three separate division problems. So we apply our laws of exponents, and we can work with 10 over 5 is 2, x cubed divided by x. I have two more factors of x in the numerator, so dividing I get 2x squared minus, and then 25 over 5 is 5. I have one more factor of x in the numerator than the denominator, so minus 5x plus, and then 35x divided by 5x is just 7. The x's cancel here. So my final answer, 2x squared minus 5x plus 7. Now that's all nice and well and good when everything divides in evenly as the 5x did. In our second sample problem, everything doesn't divide in equally. As you can see here, I have my common denominator 4x cubed, but wait a minute, 7 over 4, that doesn't work out so well. Same with x squared over x cubed. So rewriting this again, we have 4x to the fourth over 4x cubed. That one works out pretty well. Minus 7x cubed over 4x cubed. That one's going to be okay, but not great. And plus 12x squared over 4x cubed. Well, we might have to take another look at that one. So the 4 over 4 cancels. That becomes 1. And then x to the fourth over x cubed leaves us with just x over 1. Minus, well, here the x cubes all cancel. And that just becomes 7/4. And in our final term, 12 over 4, that's 3 in the numerator, and then x squared over x cubed leaves me with one factor of x in the denominator. So not quite as pretty, but it does get the job done. So our final answer is x minus 7 over 4 plus 3 over x. We could probably rewrite that x plus 3 over x minus 7/4 as well. Either way will be acceptable. And another thing we're going to have to take a look at here is long division. You probably learned long division in 5th or 6th grade, maybe 4th grade. But long division, I kind of joke around that this is gazinta math. Okay, and I'll show you what gazinta math is in just a minute. But as a matter of vocabulary here, three different ways to show division. Using our vocabulary, the dividend divided by the divisor equals the quotient. The dividend divided by the divisor equals the quotient. We can write it in fraction form. Or using our long division bar, the dividend divided by the divisor equals the quotient. So here we have 785 divided by 18. So that would be 785 divided by 18, or as a fraction, 785 divided by 18. And sure enough, our divisor is 18, our dividend is 785. So let's do an example of long division. And this is the gazinta math part. I'm going to start with long division. I have to ask myself, how many times does 18 go into 78? So 18 goes into 78 That's a really good question. It goes in 4 times. So 18 goes into 78. There's the goes into math 4 times. What's 18 times 4? Well, we multiply back and get 72. And then what we do is we subtract that entire 72. And 78 minus 72 is 6. And then we bring down the 5. And we ask ourselves again, how many times does 18 go into 65? Well, 18 goes into 65 3 times. So 18 times 3 multiply back is 54. So then we subtract 54. Notice I'm putting that in parentheses and then subtracting the entire quantity. That's a skill that we're going to need in just a few minutes. So 65 minus 54 is 11. And so we have a remainder of 11/18. So 18 goes into 785 43 times with a remainder of 11/18. So now let's apply that same concept to polynomial long division. We want to divide 2x squared plus 7x plus 30 by x plus 6. So let's rewrite this. X plus 6, 2x squared plus 17x plus 30. So our divisor is x plus 6. Our dividend is 2x squared plus 17x plus 30. And as we did before, when we said how many times does 18 go into 785, we're going to start with just the first term here. We're going to just start with the x and say how many times does x go into 2x squared? Well, x goes into 2x squared 2x times. And then we'll multiply back. So we have 2x times x is 2x squared, but we also have to multiply the 2x times the 6. And 2x times 6 is 12x. Now we subtract that entire quantity. So we change all our signs and go ahead and add. So the 2x squareds will drop out, and we get 17x minus 12x, and we get 5x, and then we'll go ahead and bring down the 30. So when we subtract that quantity, we get 5x plus 30, and we start that process all over again and ask ourselves, how many times does x go into 5x? Well, x goes into 5x 5 times. So then we go ahead and multiply back. 5 times x is 5x, but we have to multiply the 6 as well. So 5 times 6 is 30. We have to subtract that entire quantity and change our signs and add. Everything drops out. So apparently x plus 6 goes into 2x squared plus 17x plus 30, 2x plus 5 times. And if you remember your multiplication and with FOIL, we can see that 2x plus 5 times x plus 6 is going to equal all of that. Let's try another example. We'll do the same process. How many times does x plus 2 go into 4x cubed plus 3x minus 8? Well, we want to put this in decreasing order of x, but you'll notice there's no x squared term. So we're going to need a placeholder for x squared. So let's go ahead and set it up. X plus 2. And then we have 4x cubed and our placeholder plus 0x squared plus 3x minus 8. So we need one placeholder here. And we begin our process. How many times does x go into 4x cubed? Well, it's going to go in 4x squared times. So we multiply 4x squared times x, we get 4x cubed. We multiply 4x squared times 2, and we get 8x squared. We subtract our entire quantity. Notice I put it in parentheses, so we have to change all of our signs, and then go ahead and add. So we get a negative 8x squared plus 3x minus 8. Brought down my 3x, brought down my 8, my negative 8. And I ask myself again, how many times does x go into negative 8x squared? Well, it goes in a negative 8x times. So negative 8x times negative x is negative 8x squared. Negative 8x times 2 is a negative 16x. And I subtract that entire quantity. So I change all my signs and add, and I get 19x minus 8. And I start that process all over again. How many times does x go into 19x? Well, it goes in 19 times. Multiply back 19 times x gives me 19x. 19 times 2 is positive 38. I subtract this entire quantity. So I have to change all my signs and add, and I get a negative 46. So my final answer then becomes 4x squared minus 8x plus 19, my quotient, and then minus 46 all over x plus 2. That is my remainder. So got to remember that remainder. It didn't end up to be 0 here at the end. So we get 4x squared minus 8x plus 19 minus 46 over x plus 2. We can also do this same kind of thing using function notation, where f divided by g of x equals f of x over g of x. So if you're asked to find f divided by g of x, that means we have to take the trinomial, the function 2x squared plus 17x plus 30, and divide it by 2x plus 5. So, for example, this is asking us to perform this function, 2x plus 5 divided into 2x squared plus 17x plus 30. And it's asking for our answer in terms of x. So we'll do our Gazinta math. So we'll ask ourselves, how many times does 2x go into 2x squared? Well, it goes in x times. And then I multiply back 2x times x squared. Oops, that's not right. That goes in just plain old x times. So we get 2x times x is 2x squared. And then we have to multiply the 5 as well. So x times 5 is a positive 5x. We subtract our entire quantity. So we change all our signs and add. The 2x squareds drop out. I end up with 12x. I bring down my 30. And I start the process all over again. How many times does 2x go into 12x? Well, it goes in 6 times. Multiply back 6 times 2x and 6 times 5. 6 times 2x is 12x. 6 times 5 is 30. And I subtract my entire quantity, and everything will drop out. I get a 0 as remainder. So when I divide 2x squared plus 17x plus 30 by 2x plus 5, my quotient, my answer, is x plus 6. So f divided by g of x is equal to x plus 6. So if I'm asked to find f divided by g of negative 1, well, I can put negative 1 in each one of these. I could do this, 2x squared plus 17x plus 30 all over 2x plus 5, and then go ahead and put negative 1 in for x. So I have 2 times negative 1 squared plus 17 times negative 1, and figure out my answer. Negative 1 squared is 1 times 2, so that becomes 2 minus 17 plus 30 all over negative 2 plus 5, which is 3. So this becomes 32 minus 17 would be 15 over 3 is 5. However, the easier way to do this, I have f divided by g of negative 1. Well, didn't I already figure out what f divided by g is? So I could make my life easy here and just take x plus 6. That's really asking for f of negative 1 of x plus 6. So negative 1 plus 6 is 5. I had already done the heavy lifting over here, so that made that quite a bit easier if I would have just taken advantage of that. But you can see here that either way works. Obviously, if you've already figured out f divided by g of x, and then to take f of negative 1 is pretty much a piece of cake. So there's an example of using function notation and long division, and I will see you in class.